When you create a linked list data structure, it creates something called first, or it creates something called a head. And what that is basically a reference to the first node, or the reference to the first element that exists in your linked list data structure. And a node has two bits of information, a value and a reference to the second node. And the second node has the value of it and also a reference to the third node, and so on and so forth. So how is this even related to the efficiency of a linked list? Well, guys, think about it. If I want to add an element right here between the first node and the second node, all I gotta do is basically put the element here and update the reference to the node before it, and also update the reference of the new node. That means that the efficiency of a linked list at adding an element is extremely fast and extremely efficient. So whenever you want to remove a node, all you gotta do is basically, like for example, if we decided to cancel this node out, the first node out, all we gotta do is basically connect the head to this node right here. And what will that do is basically allow us to delete this, and then the garbage collector, there's something called a garbage collector that will take care of this and just get rid of it. So this is why adding and removing elements in a linked list data structure is really efficient. So let me tell you what is the worst thing that you can do in a linked list data structure. The worst thing that you can do is getting an element back. If you guys are saying, what the heck does that mean? Why is it so bad? Well, guys, think about it. For example, if I want to get this element right here, and when I say get, I means return the value back. I want to know the value of this index right here, index of 0, 1, 2, 3. I want to get the index of 3. So look what will happen. The first thing, it will go to the head. It will say, okay, where is the first node? It says, okay, this is one. Is this what I want? No, 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 no. Is this what I want? No, 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 no. Is this what I want? No, 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 no. Oh, this is the thing that I want. Okay, now we're gonna return it back. You see what happened? It had to go through 1, 2, 3, 4, and it took so much time. That's why getting an element back in a linked list data structure is extremely inefficient or really terrible. It takes so much time. On the other hand, if you look at an array, it takes instant time. Like, it doesn't have to go through the first element, the second element, the third element, the fourth element. In an array, all it has to do, it just goes immediately to the element and returns it back. And we guys gonna learn why is that true for an array in future tutorials. So now you've learned what happens behind the scenes in a linked list data structure. You've learned what a first, what a head means, what a node means, and also, most importantly, you learned that adding and removing elements in a linked list data structure is extremely efficient. However, getting an element back in a linked list data structure is inefficient because it takes so much time. It has to go through each and every element to do that. So thank you guys for watching. Don't forget to subscribe, and I'll see you next time.